Quick one reminder, this black card does not need to be written down. Promethean board rules apply, meaning everything you see in this video, from the beginning title all the way to the 12th guided practice, needs to be in your notes. Okay? Definitions, theorems, postulates, vocabulary, diagrams, all that. Everything needs to be in your notes. That's why I started taking off, because everything in here is important and related to your homework, quizzes, tests, yaza, yaza, yaza. If I don't explicitly state in the video, explicitly state, it must be in your notes. Must be in your notes. Ladies and gentlemen, once again, Fraser Nation Entertainment. This is your host, Timothy Fraser. We've come once again to the geometry series. We're going to be working with 2.2 today, analyze conditional statements. At the end of this lesson, there's two things I need you to know. Number one, you should be able to write definitions as conditional statements. Might be thinking, hey, Mr. Fraser, what is a conditional statement? Trust me, you'll learn what a conditional statement is by the end of this lesson. The essential question, how do you rewrite a biconditional statement? Okay, so we have conditional statement, we have biconditional statement. These are two terms that you will be able to identify at the end of this lesson. Okay, I know I don't have a little red box right here. Let's put a little red box right there. There's some things I want you to remember. The red box, so whenever you see something like this and you have two lines and you see that red box, that means a right angle does exist. Okay, it's not 89 degrees, it's not 93 degrees, it's strictly 90 degrees. Supplementary angles are angles that sum to 180 degrees. Remember, complementary is 90 degrees, but remember I told you guys, supplementary angles are going to be a little bit more important in our roles as mathematical geniuses in this course. Midpoints split segments into two congruent angles. Remember, this right here means congruent. And finally, vertical angles are two angles with the same vertex that make two straight lines. Okay, so vertical angles look a little something like this. Okay, so here's one angle, here's the other angle, and they both share the same point. Cool? Do you have any questions so far? All right. Next card. Key vocabulary. I know it's a lot of information to take down. Go ahead and take your time. Get through it. This is probably what needs to be on flashcards. So let's just get through it. Conditional statements. A logical statement, and I know. There is not a young E in there. Let's go ahead and put an E in there, and let's put an E in here too. A logical statement that has two parts called the hypothesis and the conclusion. Yes, it is kind of related to science, but that's probably as far related to science as it is. Hypothesis and conclusion, they share the same name. Might be wondering, hey, what does this have to do with mathematics? Mathematics is a logical exercise. Just about every other subject you deal with has bias, but mathematics, straight to the point, no bias. All right, so conditional statement, logical statement that has two parts, the hypothesis and conclusion. Negation, okay? Negation is when you have the opposite of a statement, okay? So one example here is, my statement is, it is raining. The negation of that is, it is not raining. Okay. Another statement could be, I am not driving. The negation of that is, I am driving. So it's just some things that you need to be aware of. Next, if you have the conditional statement, then here are some key things that you need to remember. The converse of a conditional statement, that's when the hypothesis and the conclusion are switched. Okay. And what do I mean by switch? Well, come on down here. The if-then form, that's the typical form that a conditional statement uses. The hypothesis and the conclusion. So it will say, If a dog is large, then it is a Great Dane. So the if part would be the hypothesis, the then part is the conclusion. So the converse of a conditional statement is when you switch both the hypothesis and conclusion. The inverse is when you negate both. You don't switch them, but you negate them. And the contrapositive is when you switch and then negate both hypothesis and conclusion. I know it's a lot of information on the screen right now. It's going to make a little bit more sense in my guided practice. So don't be daunted. Don't be intimidated. Let's just go ahead, get this down in your notebook, and move on to the next card. Key vocabulary. Equivalent statements. In general, when you have two statements that are both true or both false, they are equivalent statements. That's going to make sense a little bit later on. I'm just giving this to you now because the book wants you to have it. The conditional statement and its contrapositive, those typically are going to be equivalent statements. Okay, you'll see why a little later. In the biconditional statement is when a conditional statement and its converse, so remember, converse is when you switch the if and then statements, are both true. It does contain the term if and only if. So if you see this term in a statement, just know that you're working with a biconditional statement. Okay, really important. Next card. Diagram-wise, perpendicular lines. These are two lines that intersect to form a right angle. Right here, you see the right angle right here. These are perpendicular lines. You can also switch this definition and it will still be true. So if they are perpendicular lines, then they form a right angle. Okay? So this statement is true. The converse is also true. And look what happened. I said converse. Converse is when you switch the hypothesis and the conclusion, you switch the if and then. So instead of saying this if, then we switch it. We say if two lines are perpendicular lines, then they intersect to form a right angle. The symbol, okay, remember, mathematicians are pretty lazy at times. Instead of saying is perpendicular to, we can just write this symbol right here. So with my line K and my line M, there are two lines that intersect to form a right angle. Here's my symbol, so I can just say K is perpendicular to M. Then I'll know that, hey, here's a line, they form a right angle. Okay, isn't that a lot simpler to write than is perpendicular to? Next. All right, guided practice. This is the part that is pretty much related to your homework. So let's go ahead and work through these. We say that all right angles are right angles. We want to switch all these into if-then form. So we would probably say if an angle is 90 degrees, then it is a right angle. Okay? We probably bump that up to 25. Okay. And let's do this in blue. All right, so here's the answer. If an angle is 90 degrees, then it is right angle. Let's say if, then form. Okay, next. So 2x plus 7 equals 1 because x is equal to -3. Your if-then form would be if 2x plus 7 is equal to 1, then x is equal to -3. So you see, the front part of your statement is probably going to be the if. The second part is going to be a then. Let's try another one. Okay. So instead of saying when n equals 9, n squared is equal to 81, let's say the if-then form. And let's go ahead and bump that up to 25 years. If n equals 9, then n squared equals 81. Let's go ahead and put that in superscript. Okay. And then finally, let's try this one out. Okay. Go ahead and give yourself a second to think about it. Give yourself a second to think about it. Okay. So, if then form, if tourists are at the Alamo, then they are in Texas. Okay. So really this guided practice was all about trying to change these statements into if-then form. Okay, so now we have 4 conditional statements. Questions? Let's move on to the next slide. Okay, right here, this is where we get familiar with the converse, the inverse, and the contrapositive. So I have 2 conditional statements here for 5 and 6. And I need to be able to tell if that's true or false. Okay? So the converse. This is when you switch the if-then form. So converse, if a dog is large, okay? I'm switching my if and then statement. So if a dog is large, then it is a Great Dane. Now remember I told you in the last section that if I can prove one case to be contrary or false, then the whole thing is false. So my conjecture is if a dog is large, then it is a Great Dane. I can tell you right now that that is false. Okay, a dog could be a great Dalmatian. Those are large dogs. They're large poodles. So it doesn't necessarily have to be a Great Dane. So that is false. The inverse is when we negate both our if and then statements. So let's try this out. If a dog is not a Great Dane, then it is not large. Okay. And again, like I said, poodles can be large, Dalmatians can be large, I guess terriers are large. So this statement is not necessarily true because a dog doesn't have to be a Great Dane for it not to be large. So this is false. In the contrapositive, if, remember, this is when we switch and then negate. So if a dog is not large, okay, then it is not a Great Dane. Now look at what we just said. If a dog is not large, it is not a Great Dane. There is, in general, an understanding that if the conditional statement is true, then the contrapositive is also true. So basically what I'm trying to say is, if a dog is not large, then it's not a Great Dane. The dog is not large. A Great Dane has to be large. So this is also a true statement. Okay. Number 6. If a polygon is equilateral, then the polygon is regular. Okay. Regular, and I don't know if you guys noticed or not, so let's go ahead and put that on out there for a second. I'll put it right here. Regular means congruent sides and angles. I just feel like you guys really should know that right now. So that's why I'm just kind of writing it off to the side. Let's think of the converse. Converse is when you switch. Okay? Converse is when you switch. So if a polygon is regular, then it is equilateral. Okay? Equilateral means that all your sides are congruent. But the definition of regular means that you have to have both congruent sides and congruent angles. A polygon can be regular without its angles also being congruent. So the converse here is false. It can be equilateral and not necessarily regular. Next, if a polygon is not regular, is not equilateral, then it is not regular. Okay. Same thing here. If it's not equilateral, then it's not regular. Like we said in the converse, a polygon can be regular and not equilateral. Equiangular. Okay. So if a polygon is not equilateral, then it's not regular. That's a false statement. And then the contrapositive, remember we switch and then negate. If a polygon is not regular, then it is not equilateral. Okay. Well, you can't be regular without being equilateral. That's just kind of in the definition itself. Equilateral does mean congruent sides, so this is a true statement. Questions? I would rather put the homework in your hands and give you time to kind of sort through that. So if you have any questions, please let me know. Next. Okay. Use the diagram shown, decide whether the statement is true or false, and then explain your answers using the definitions that you have learned. Okay. So where's my pen at? Right. Number 7. JMF. Let's go ahead. And FMG are supplementary. So FMG, JMF, they're supplementary. Is that true or false? Well, in this one, we should say true. Okay, and let's not do that. Let's go ahead and type this sucker in. And we're saying that it's true and why are we saying it true? Because linear pairs, line people, straight line. A straight line is 180 degrees, so we can say that linear pairs are supplementary. Okay? Remember, supplementary means 180 degrees. And linear pairs are supplementary because straight lines are 180 degrees. Okay? Point M. Point M is the midpoint of line segment FH. Okay? I'm telling you right now that is going to be false. Okay? And it's false because, hey, what do I know about FM and MH? I don't know anything. Okay? I don't know anything. For this to be the midpoint, I would have to know that FM and MH are congruent. Okay? Being that I don't know that, then, hey, I can't say that M is the midpoint. So I would say line segments FH is not congruent to line segment, and I didn't mean to say FH. FM is not congruent to line segment MH. Okay, since I don't know that, I cannot say that M is the midpoint. So that's false. JMF, so JMF and HMG are vertical angles. That right there will be a true statement. Why is it a true statement? Well, we have two angles, so let's identify our two angles right now. Okay, here's our first angle, here's our second angle, and they are making two straight lines. So here's my two angles, same midpoint, and they are making two straight lines. That's the definition of vertical angles. So they are making two straight lines. And then finally, remember your symbol right here. FH, let's go ahead and erase this right now. FH, so here's FH, and JG, they are perpendicular. Is that true or false? Well, you're probably thinking that it's false, and if you said that, I agree with you. It's false because we don't know if this is a right angle. We don't know if this is a right angle. So the diagram does not tell us that they meet at a right angle. And in the definition of perpendicular, okay, they have to meet at a right angle. Since this is not telling us it's at a right angle, it's not at a right angle. Next card. Rewrite the definition of right angle as a biconditional statement. Okay. So we know that if it is a right angle, then it has to be 90 degrees. We know that if it's a 90-degree angle, then it's a right angle. So let's go ahead and write this down. So my biconditional, an angle is a right angle if and only if. Okay, and I wanna be real clear with this. This statement is making it a biconditional statement. So if and only if it is 90 degrees. An angle is a right angle if and only if it's 90 degrees. So I could say if it is 90 degrees, then the angle is right angle. I could say if an angle is right angle, then it is 90 degrees. The biconditional puts them together with the if and only if, and there you go. Number 12 is going to be similar to that. Let's look at it. So if Mary is in theater class, then she'll be in the fall play. If she's in the fall play, then she must be taking theater classes. So we got to put these two together, okay? So biconditional. If Mary, no, and there's no if at the beginning, I apologize. Mary is in theater classes if and only if she is in the fall play. Okay? Remember that if and only if basically makes your biconditional statement. Okay? I'm going to go ahead and upload your 2.2 homework. Remember that these notes are due the next time I see you. Everything needs to be in your notes. I've had a good time. I'm sure you've had a good time learning some new material. You know how I do it. Let's go ahead and put our little smile up. And actually, let's just be a little bit more creative this time. Check it. Just do it. Basically, just do your homework. I'll talk to y'all later. This is Fraser Nation.